Before we get started on tree diagrams, there's a few things to know about probability. The general formula of any probability is the number of favorable outcomes divided by the number of possible outcomes. To understand how probability works, we'll look at two examples involving a die. What are the odds of rolling a 6 on a die? You are interested in only one outcome of a total of 6 possible outcomes, because a die has 6 sides. So the answer would be 1 over 6. This probability can be expressed as a fraction, a decimal, or a percentage. Now, what are the odds of rolling a 6 or a 5? We have two favorable outcomes that we are interested in, and the die still has 6 sides. So the answer is 2 over 6, which can be simplified to 1 over 3. You could have also said 1 over 6 plus 1 over 6, because the word or is normally linked to adding probabilities. If you've noticed, any probability will always be between 0 and 1, both included. If the probability is 0, then it's not going to happen. And when the probability is 1, then it is certain to happen. 1 can also be expressed as 100%. Moving on to our first example. We have two bags of marbles. Bag A contains 3 red marbles and 2 blue marbles, while bag B contains only 2 red marbles and 4 blue marbles. You randomly select one bag and then randomly select one marble from that bag. Create a tree diagram to find the probability of selecting a red marble. I like to start off with writing down what is given. Bag A has 3 red, 2 blue, and 5 balls in total. Bag B has 2 red, 4 blue, and 6 balls in total. We can start off our tree diagram by showing that either bag, A and B, can be chosen at random. So we know that both bags has a 50% chance of being chosen, or you can say a half. Bag A includes red and blue balls, with the probability of red being chosen is 3 over 5, because there are 3 red balls and 5 in total in bag A. Similarly with blue, its probability of it being chosen is 2 over 5, because there are 2 blue balls in bag A. Bag B also includes only red and blue balls, so we only have 2 branches like so. The probability of getting a red ball in bag B is 2 over 6, because there are 2 red balls and 6 balls in total for bag B. 2 over 6 can be simplified to 1 over 3. The probability of getting a blue ball in bag B is 4 over 6, because there are 4 blue balls in a total of 6 balls in bag B. 4 over 6 can be simplified to 2 over 3. The question asks us to find the probability of getting a red ball, and there are 2 different ways or paths of getting a red ball, namely getting a red out of bag A and getting a red out of bag B, and these paths are indicated by the red arrows. When you see the word "and," it will generally end up in you multiplying the probabilities. So the probability of getting a red ball out of bag A would be a half times 3 over 5, and the probability of getting a red ball out of bag B will be a half times 1 over 3. Type this expression into your calculator and you will arrive at your answer, which is 7 over 15. You can write your answer as a fraction, a decimal, or a percentage. Just make sure if they state otherwise in the question. Question 2. You are taking a multiple choice test with 5 questions. Each question has 4 answer choices. Create the tree diagram to find the probability of answering all questions correctly if you guess on each question. So there are 5 questions, which means that you have 5 scenarios and thus have 5 tree branches for each question. Because there are 4 different choices for the answer per question, your chance of randomly choosing the right answer is 1 over 4, and that will be the probability for all 5 questions. So the probability that you will guess all 5 questions correct will be 1 over 4, or a quarter, to the power of 5, because you need to multiply the quarter by itself 5 times. Yet again, you can see that the word and, yet again, see that the word and is linked to multiplying possibilities. Typing this into your calculator will give you 1 over 1024. When expressed as a percentage, it is 0.098%. So it's better to study for your tests. The last question, a box contains 3 white balls, 2 black balls, and 4 green balls. You draw 2 balls without replacement. Create a tree diagram to find the probability of drawing a white ball on the second draw after drawing a white ball on the first draw. This question is a bit trickier because you are dealing with not replacing the balls. I'll start off by writing down what is given. The box has 3 white balls, 2 black balls, and 4 green balls, which is 9 balls in total to start with. So there's 3 different possibilities that can take place when drawing a ball out of the box, namely drawing a white, black, or green ball. The probability of drawing a white ball is 3 over 9, because there is 3 white balls and a total of 9 balls at the start. 3 over 9 simplifies to 1 over 3. For black, it is 2 over 9, and for green, it is 4 over 9. The path that we are interested in is drawing a white ball at first and then drawing a white ball again the second time. So I'm just going to do this part of the tree diagram. The different paths you can take after drawing a white ball is still drawing a white ball, black ball, or green ball, like so. Remember, because we are not replacing the balls drawn, our total is going to be 8, or you can say 9 minus 1. And the total white balls after drawing a white ball at first is going to be 2, or you can say 3 minus 1. So the chance of drawing a white ball again is 3 minus 1 over 9 minus 1, which can be simplified to 1 over 4, or a quarter. The chance of drawing a black ball after drawing a white ball is 2 over 9 minus 1, which can be simplified to 1 over 4, a quarter. And similarly for green, it will be 1 over 2, or a half. The path that we are interested in is drawing a white ball and then drawing a white ball again. The path is indicated by the red arrows. Yet again, and usually means multiply, so we multiply these 2 probabilities. 1 over 3 times 1 over 4 is 1 over 12, which can also be expressed as 8.33%. Thank you for watching, and I hope you understand probabilities and tree diagrams a bit better now. Good luck on your math journey.